Hi, my name is Farzana Farahani, and I'm a project geophysicist here at Seequent. In this short video, I'm going to show you how to incorporate your constraint drill hole data into a VOXI inversion model. Applying downhole physical property constraints is a common requirement in VOXI inversion. The exploration aim is to improve the inversion of the field data by incorporating constraints and thereby reduce the non-uniqueness of the geological interpretation. In the following video, I describe a process involving 3D kriging of downhole physical property measurement into a voxel model, which is in turn imported into VOXI as a parameter reference model and used to guide to the inversion. You do not need the drill hole extension on your Oasis Montage subscription in order to use the VOXI drill hole constraint builder. Any database that has X, Y, and Z and either susceptibility or density channels can be used to build a VOXI set of drill hole constraint voxels. There are several ways to incorporate your drill hole data to your VOXI constraint inversion model. In this example, we have some borehole susceptibility data, and we are going to create a parameter reference model and a parameter weighting model using that data. I'm using the same mesh that I have used in creating my unconstrained inversion. By clicking on Constraints, Create Drill Hole Weight Models, a window will pop up for us. We need to browse to the database that we have our physical properties saved in, and for the property channel, I have susceptibility data. The cell size is the size at which to grid the above property. By default, it's to set the horizontal cell size of the VOXI mesh. Then we'll give a proper name to the parameter reference and parameter weighting voxel here. By clicking on More, you see that there are several options here for you. There is a background removal calculator here. As you know, the inversion models the contrasts of the geophysical property. As a result, it's recommended to remove the mean of the measured property as recorded into drill hole data. Also, you see a radius around the drill hole. The influence of the drill hole property should only extend a reasonable distance away from the drill hole. By default, the constraint is extended a distance of 4 cells. So if I click here, you can see that the radius is 40, which is 4 times of 10. The weight attenuation factor is also set to 1 here. The weight assigned to the reference model decreases exponentially away from the drill path. You can control how quickly the weight decreases by providing the power of the weight attenuation. By default, this is set to 1. Also, you see a weight minimum threshold here. This is the value to which the weight attenuates. If I click on OK here, VOXI starts to create the parameter reference model and the parameter weighting model. It will take a few minutes depending on the size of your drill hole data. When the process is done, you'll see that there are 2 voxels added to your VOXI project, a parameter reference model and a parameter weighting model. If you click on your parameter reference model and clip your data, you'll see that it gives you the shape of the drill holes that you have. Also, there is something to pay attention about your parameter weighting model. If I click right, modify, you'll see that there is a weighting option here. During constraint inversion, the need often arises to vary the global weight of the parameter reference weighting. Rather than requiring you to generate a new target weight with scaled values, the inversion allows you to globally scale the 0 to 1 range of the target weighting by a constant value. This value is referred to the global target weighting. If you are very confident about this weighting, you can just change it to 1 and then click OK. Now you are just ready to click on the inversion and run your constraint inversion. As you see here under the constraint list, there are several other constraint options that you could choose, but it's recommended just to run your inversion, just choosing this parameter reference model and parameter weighting. If you're happy with the results and if you have more constraints to add, then you can add that to the resulting. I hope this video was helpful and thank you so much for watching.